In this lesson, we will be subtracting rational expressions. In the previous lesson, we were adding same steps, just a little bit of a different thing that you have to apply towards the end. So we're going to start off by pretty much writing the same thing. So please make sure your heading's on here. Please pause it if you need to. Can you write in order to subtract fractions? In order to subtract fractions, you must have a common denominator. You must have a common denominator. So you cannot add or subtract fractions unless they are the same. I will not show you the examples we did before. We'll just go right to the steps. So same steps. I want to put them on these notes as well, but we just have to add one little tiny thing towards the end. So I'm going to just go ahead and list the steps as we do an example. So I'm going to have 4 steps. Step 1 will just need 1 line. Step 2 will have about 2 lines. Step 3, we're going to have about 4 lines. And then step 4, just 1 line, and then we're going to just have one little important note here. And I'm going to need about 2 lines for that. So let me move this down. So again, maybe a line for step 1, a couple for step 2, a couple, about 3 for step 4. I'm sorry, 3 for step 3, 1 for step 4, and then we'll need a couple of lines for an important point here. And I'm doing all of this just so that way we have our example as we're doing our steps. So down below, I'm going to write, for example, A. Above that, I'm going to put combine and simplify. Combine and simplify. So I'm going to start off fairly simple. We're going to have our first example is going to be 7x plus 9 over 3x. This time we're subtracting, so we need our subtraction sign. Let me move this up a little bit. And then we'll have 5x plus 6 over 3x. So that's going to be our first example. We're going to do 4 examples in the notes. So let me go back up to my steps. Step 1 is the same as if we were adding fractions. We're going to find the LCD. So step 1, find the LCD. If you look at this example, you'll notice our LCD, least common denominator, they have to match, and they do. So our LCD is 3x. I'm going to put that at the top just so we know that we found it. If they were different, then we would have to go ahead and do some multiplying. So step 2, multiply the numerator and denominator. I'm going to put multiply the top and bottom just to shorten it. So multiply the top and bottom of each fraction. By the same factor. That will give the LCD. So if you look at this first example, we already have the LCD, so we can skip that step. If they were different, we'd have to use that. Step 3, subtract the numerators. So you can write subtract the numerators. You can abbreviate this. Subtract the numerators while keeping the denominators. The same. Here's the important part though, and that's why I had you add an extra line. When we are subtracting, we're going to be changing the signs. So if you could put a little dash here, can you write, remember to change the signs. Remember to change the signs of the second numerator. You can abbreviate all of this. I know it's a lot. We're just trying to get the steps out of the way. So here's the difference from adding. So I'm going to move this up for a minute. When we go ahead and subtract this, I'm going to have my denominator will be 3x. They're the same again. That's why we didn't change it. We're going to write all of this. I did that extra step with adding. I'm going to write all of these terms at the top, but be careful. 7x plus 9 goes first. We want to subtract all of this. So if you can imagine that we're subtracting all of these terms and there's an imaginary 1 here. So we are really distributing this -1. So this 5x becomes minus 5x. And this plus 6 becomes minus 6 because you have to give that negative to both of them. That's why it's nice to rewrite it. If you were just looking at this, you might think it was just 7x minus 5x, and then you combine the 9 and the 6. Now, step 4 is to simplify. So step 4 is to simplify. So now here we can see we can combine like terms easily. 7 minus 5 is 2, so we have 2x. 9 minus 6 is a positive 3. And on the bottom we have a 3x. I'm going to look to see if I can simplify. I can't factor the top, and there's no common factor that I can take out of all of them, so there's my answer. There's one little important thing we need to do before we do our other 3 examples. I'm going to go back up here where it says important. Can you write, if you see, and put in quotations, subtract from. Subtract from. So for instance, if I said to you, subtract 5 from 20, what you would really be doing is 20 minus 5. So that last number goes first. So after this, can you write, that means second expression goes first. Second expression goes first. And I will show you an example like that. So we're going to do 3 more examples of subtracting. I'm going to switch papers and go to another page and do example B. So we'll go a little bit slower here. For example B, leave some space above it, please. Can you write 3x plus 7 over x squared minus 4? We're going to subtract another fraction next to it on the top, x plus 3. On the bottom, x squared minus 4. Starting off fairly simple, just so you get the idea of subtraction. So step 1 is to find the LCD. Since they were already the same, I don't need to worry about factoring, so that is my LCD. So above, I'm just going to write LCD is x squared minus 4. That means since they are already the same, I do not need to worry about multiplying my fractions. So I'm going to go right to step 3, which is to subtract. So I'm going to make one fraction. My denominator is going to stay x squared minus 4. And I'm going to bring down these terms. And again, think of it as this is in parentheses and you have like a 1 in the front. So we're multiplying by -1. So I bring down the 3x plus 7. And now instead of x, it becomes minus x. And instead of plus 3, it becomes minus 3. Now I can combine like terms to simplify. So I'm going to combine the top. 3x minus 1x is 2x. 7 minus 3 is a positive 4. Then on the bottom, I'm going to bring over my denominator, x squared minus 4. Before I'm done, I want to see if I can simplify this. And it looks like I can factor, so I'm going to try that out. So on the top, I'm noticing my GCF is 2. So I'm going to take out a 2. And in parentheses, I'm going to put x plus 2. I divided out a 2 from both these terms. What I'm trying to do is simplify. So I'll cross off the old top. On the bottom, there's no GCF, but there's a power of 2 with subtraction. So I can do 2 sets of parentheses, x and x in the front. Factors of 4 that subtract to give me nothing in the middle means it has to be the same number. So 2 and 2, and opposite signs, 1 plus, 1 minus. So I just changed the bottom. Now, if you take a look, there is a factor that's in common, top and bottom. I can cancel. That's our x plus 2. So I'm going to get rid of those. Nothing else is in common, so we're ready for our answer. We have a 2 on the top, and we have an x minus 2 left on the bottom. So the important thing, get a common denominator. Remember to switch the signs of your second expression. and then you're combining and factoring. All right, here's another example. C, we're going to do a total of 4. So example C, can you write for me, find the difference of, and can you write x over x squared minus 4, and put the word and, another fraction, 6 goes on the top, x squared plus 8x minus 20 goes on the bottom, and then the directions finish it off. Can you write in simplest form? In simplest form. All right, so difference means subtract. So I'm going to rewrite this as a subtraction expression. This one goes first because it just says find the difference. So I'm going to put leave some room. I'm going to have my x over x squared minus 4. And then I'm going to subtract my 6 and my x squared plus 8x minus 20 after it. We can't subtract until we get a common denominator. So we need these to be the same. So what we're going to do is factor each, and then our LCD will come from here. So if I go over here on the bottom, I can make 2 sets of parentheses. I did that up top here. That would be just x plus 2 times x minus 2. I'll lightly cross this off. Over here, there's no GCF, but there's a power of 2. So let me try to factor this one. So x and x go in the front. Factors of 20 that subtract to give us 8 would be 10 and 2. We want a positive 8, so that would be 10 minus 2. So 10 is positive, 2 is negative. So I'm going to get rid of my old bottom. My LCD would be everything from the first fraction on the bottom, including anything that we're missing. So if you notice, we need an x plus 2, an x minus 2, an x plus 10. We already have an x minus 2, so we don't need that. So our LCD, I'm going to put that up top, is everything I just underlined. So we have our x plus 2, our x minus 2, and our x plus 10. And again, I didn't bring this back up because we already had an x minus 2. So now our step 2 is to multiply our fraction top and bottom by whatever's missing in the denominator. So if you look here, we have an x plus 2 and an x minus 2, but we're missing the x plus 10. So we are going to multiply the top and the bottom of the fraction by x plus 10. Over here, I'm missing from the LCD an x plus 2 because I have the x minus 2 and the x plus 10. So I'm going to multiply everything, top and bottom, by x plus 2. So I write it twice, one on the top, one on the bottom. Now I'm going to clean this up. So what I'm going to do is rewrite my fractions. I'm going to have 2 fractions. I'm going to have my LCD. You can write any term you want first. So I'm going to put x plus 2, x minus 2, x plus 10. I'm subtracting my other fraction, so I'll do the same thing. So all I'm doing right now is just rewriting my LCD. If I'm going too fast, don't forget to pause the video. Now what we have to do to get our new numerators, we're going to multiply what we had on the top. So if we multiply x times x is x squared, x times a positive 10 is positive 10x. Over here, we're going to multiply everything by x plus 2, so 6 times this. So 6 times x is 6x. 6 times 2 is positive 12. I deal with this minus at the end. Since we have common denominators, now we can try to combine. So I'm going to make one fraction. My denominator is going to be my LCD, so I have x plus 2 times x minus 2 times x plus 10. What I'm going to do is bring all of these terms down, but don't forget you have to change the sign since we're subtracting. So I'll bring down the x squared and the plus 10x. Instead of 6x, remember if you want to put parentheses around it and put a little imaginary 1 there, the 6x becomes a negative 6x. The positive 12 becomes a negative 12. Now what we can do is combine. So I'm going to rewrite my fraction. I know it takes a long time, but showing these steps might help us. So I'll bring down my old LCD again. So x plus 2, x minus 2, x plus 10. And now I'm going to combine like terms. So I see an x squared. I can combine my x's. 10 minus 6 is 4, so positive 4x. And then minus 12. Now I just need to see if I can factor anything to cancel out any common factors. So if I look at the top, there's a power of 2, no GCF. So I'm going to try 2 sets of parentheses. So if it's getting crowded for you, try to maybe put it on the side, but you want to leave room in between any space. So x and x go in the front. Factors of 12 that subtract to give me 4 would be 6 and 2. 6 minus 2 is 4, so 6 is positive and 2 is negative. I'm going to cross off my old top. So now if you look at our answer, I'm looking to see what's in common. Well, I notice that there's an x minus 2 on the top and the bottom, so I get to cross those out. I don't see anything else in common. So now my answer is whatever's left over. So we have an x plus 6 left over. And we also have on the bottom x plus 2 and an x plus 10. There is our simplified answer. We've got one more, and then we're done. This will be example D. I'll go ahead and take this off. Last one, example D. Can you write simplify 2 over 10x plus 5 subtracted from, and our fraction is x minus 3 over 4x squared minus 1. All right, last example. So when you see the keywords subtracted from, that means this second polynomial is going to go first when you rewrite this. So just like when I said we have 5 subtracted from 20, the 20 would go first. So if we have this fraction subtracted from this, the second one goes first. So I'm going to rewrite this expression. So I'm going to I'll leave some room, x minus 3 over 4x squared minus 1. That goes first because it's subtracted. This is subtracted from it. Then behind that, I'm going to put my subtraction sign and bring down the 2 over 10x plus 5. Leave some room in between every space just in case we have to factor. All right, first step is to find the LCD. So I'm going to write LCD equals. In order to do that, we have to factor. So I look at the bottom. Our LCD will be 1 of everything. So on the bottom, I don't see a GCF, but I see a power of 2, and this is a perfect square. So watch what I'm doing in case you've forgotten. What times itself gives you 4x squared? That would be 2x and 2x, so that goes in the front. What times itself gives you 1? That would be 1 and 1. And we need opposite signs since there's no middle term. So I just changed the bottom. Over to this fraction, I notice I can take a 5 out of both, so that's my GCF. So I'm going to pull out a 5. In parentheses, I'm going to put what's left. 10x divided by 5 is 2x. 5 divided by 5 is 1, so I have a plus 1. So I just changed the bottom. Our LCD is everything from the first fraction plus whatever we're missing from the second. So if you notice, we have a 2x plus 1, a 2x minus 1, a 5, and we already have the x plus 1, so we don't include it again. So my LCD, I'm going to put the 5 in the front, and we have 2x plus 1 times 2x minus 1 for our LCD. So what that means is we want both fractions to look like that. So we say to ourselves, looking at the first fraction, what's missing from the bottom to get the LCD? Well, that would be a 5. So we're going to multiply the top and the bottom of the fraction by 5. And I'm going to put the top in parentheses since there's 2 terms. In this fraction, I'm noticing that I'm missing a 2x minus 1 from the LCD. So I'm going to multiply the top and the bottom by that 2x minus 1. Now we're ready to try and rewrite our fraction. So we're going to have 2 new fractions, leave some space. And again, we're subtracting. My denominator is going to be my LCD, so I'm going to bring this down twice. So we have 5 times 2x plus 1 times 2x minus 1. I'm going to write the same thing on the other fraction. I'll give you a second to do that. Make sure your fraction bar is long enough. Now we're going to bring down our new numerators. So we're going to multiply this first fraction's numerator by 5. So 5 times x is 5x. 5 times -3 is -15. Over here, we're multiplying this 2 by these two terms. So instead of 2 times 2x, that's 4x. And 2 times -1 is -2. Since we have common denominators, we're allowed to make this one fraction now. So leave room above it, and we're going to make one fraction. My denominator is going to be the same, so I'm just going to bring down the LCD. You only bring it down once. So we have 5, 2x plus 1, 2x minus 1. Now we're going to bring down the term. So I bring down the 5x minus 15. Remember to change the signs of the second polynomial. So instead of 4x, it's minus 4x. And instead of minus 2, it becomes plus 2. Next step is to combine like terms. So again, I'm going to rewrite my fraction. And of course, some steps can be skipped, but for the notes, I want you to see exactly what we're doing. So I wrote down the denominator one more time. And now we combine like terms. 5x minus 4x is 1x, or just x. Don't include the 1 if we're simplifying. -15 plus 2 is a -13. So now I'm looking, I want to see if I can factor anything. There's no GCF up here, there's no power of 2, so there's nothing I can do at the top. There's nothing I can cancel out, so this is my final answer. Please make sure you submit this work into Canvas with pictures of it.